Alright, let's look at 9.5. It's all about inscribed angles. So we know what an inscribed angle is already, right? It has its vertex on the circle with endpoints on the circle. So this new theorem says that an inscribed angle is half the measure of the intercepted arc. So let's look at example 1. It wants to know the measure of angle PRU. So in a highlighting color, I'm going to color angle PRU. Okay, it wants to know the measure of this angle. Well, we just read that the inscribed angle is half the intercepted arc. The intercepted arc here is 118 degrees. So what is half of 118 degrees? Okay, it is 59. So this angle is 59 degrees. Now it's asking for the measure of an arc SUP. So in a different color, I'm going to highlight arc SU and P. What we have to do first, before we find measure of arc SPU, is we have to find the measure of arc SP, or PS. Okay, we're going to use the theorem that we just read. The angle is half the measure of the intercepted arc. If the angle is half of the arc, that means the arc is twice the angle. So what is twice the angle? Twice the angle is going to be 54. Is that what the problem is asking for, though? No. The problem is asking for the measure of the arc SPU. So we have to add 118 plus 54 degrees. Okay, and that gets us 172. Okay. Now let's look at part C. It's asking for the measure of arc SRU. So in a different color, pink or purple, I'm going to highlight arc SRU. So we have to remember how many degrees there are total in a circle. There's 360 degrees total in a circle. So if I take 360 and I subtract 118 and 54, that should get me my measure of arc SRU, 188. Let's look at this next definition here. It says if inscribed angles of a circle intercept the same arc, then the angles are congruent. So let's break this down in the picture. I'm going to use my highlighter. I'm going to highlight the red angle in red, highlight the blue angle in blue, and the green one in green. And the intercepted arc that they all share is this yellow arc. Okay, and because they all are inscribed angles that share that same yellow intercepted arc, then the angles are all congruent. Red angle congruent to blue angle, congruent to green angle. Let's look at example 2 and apply this new knowledge that we just learned. Okay, so I'm going to highlight in yellow. I'm going to highlight angle EDF, and in red I'm going to highlight angle EGF. And then in blue I'm going to highlight the intercepted arc. They both share the same arc, which means that these angles are congruent. Okay, if two expressions happen to be congruent to each other, that just means they're equal to each other, right? So set them equal. How? Using an equal sign. Okay. I'm going to go through and solve this equation, but you should be following along on your paper. Okay, so add 2x to both sides. And then we need to get the x all by itself, right? So before I divide, I have to subtract the 3. Very last step I have to do is divide by 4, right? I want to get the x alone, so I have to get rid of the 4. 4's cancel, and I get 18. Okay, don't circle your answer just yet. We have to go back and see, is this what the problem is asking for? Okay, is it asking for what is x? It's actually asking for the measure of angle EDF. So now that we have x, we can plug it back in to find the measure of that angle. So 2 times 18 plus 3 is going to be the answer to what the problem is asking for, measure of angle EDF. Okay, so put that in your calculator. Put that in your calculator. Okay, and you get 39. That is your answer. Measure of angle EDF. Okay, let's look at example 3. Now, example 3, I really highly suggest that you use different colors, because this is just so hard to see with all these different lines on here, and they're meant to distract you from figuring out the real answer, right? So we are given one angle, and I want to highlight that angle. I'm going to do it in yellow. This is the angle that we know the measure of because it's given. And let's look at what we're actually trying to find. We're trying to find the measure of angle DBA. So I'm going to highlight angle DBA in green. Now, you should notice, just like in the last problem, these two angles intercept the same arc. So in red, here is our intercepted arc, which means that these two angles are congruent. If they're congruent, they're the same. So our answer is right on the paper. Measure of angle DBA is also 33. Let's go look at the bottom of your page. Okay. Now, this definition, the way it's worded can be difficult to wrap your head around, but it's extremely simple. It's just worded strangely, and I agree. It's worded very strangely, but the idea behind it is not complicated. So an inscribed angle subtends a semicircle if and only if the angle is a right angle. All this is saying is that if the endpoints of your circle the endpoints of your angle are on the diameter, here's the diameter. If the endpoints of your angle are on the diameter, then this here will always be a 90-degree angle, no matter what, as long as those endpoints are on the diameter. Okay, and they use this fancy word to describe that. They use the word subtends. Okay, but just know that if your endpoints of your angle are on your diameter, this is always a 90-degree angle. So let's look at example 4. Example 4, find the value of A. Okay, well, so let's do that. Okay. So where's our angle and where's our endpoints? Okay, this is the given angle, and our endpoints are here and here. Okay, where's the diameter? Right here. So are our endpoints on the diameter? Yeah, they are. They're on the diameter. So what does that mean for our angle? It means our angle is 90 degrees. Okay, but our angle is also this many degrees. Okay, but it's also 90. So that must mean that this expression is equal to 90. Okay, try to get the A all by itself. Last step is to divide by 5. And you should get 14. A is 14. Alright, we're almost done. almost done. One more theorem, and then we'll do some examples using this next theorem. This theorem says, if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. Or I have a hard time saying that word. Supplementary. Okay. What does supplementary mean? It means all the angles add up to 180 degrees. Okay. So let's look at the image, the picture here. It says ABCD is inscribed in circle E. So this polygon is inside the circle, and angle D and B are opposite angles. Okay? Angle A and C are opposite angles. What this theorem is telling us is that angle D plus angle B has to equal 180 degrees. Okay. Likewise, angle C plus angle A must equal 180 degrees. Okay. Otherwise, that polygon wouldn't be able to fit inside of that circle so perfectly, with the vertexes touching the circumference of the circle. It just wouldn't work unless those opposite angles added to 180. I think this is pretty cool. You want to know if this polygon can be inscribed in an angle. So can every vertex of this polygon touch the circumference of this angle of this circle, and can it be a perfect circle? Like, can this possibly in real life happen? Okay. The way I drew it, it looks like no, but you know, maybe it actually can happen. So let's figure this out, because I can't draw very well. So we're going to add the opposite angles. 85 plus 90. 95, sorry. Does that equal 180? Okay, it happens, it does. And let's add 110 and 70. 110 and 70, that equals 180. So, yes, this quadrilateral could be inscribed in a circle. So, you know, there's a circle, you know, and of course I can't draw it, but there's a circle where the polygon will touch the circumference of the circle, and it you know, it's a perfect circle, but I can't draw it. You have to trust me, okay? Something like that. Okay. Again, the picture might not be drawn to scale either. We just have to add them. If they add to 180, then yes, it can be inscribed in a circle. We're going to skip this one and look at the third example. Okay. 70 plus 70 is 140. So right away we say, no, you can't inscribe this polygon inside a circle. It just won't work. Okay, because it doesn't add to 180. Example 6. Example 6. Find the measures of each angle. Before we get started, turn this I into a J. It's a typo. It should be a J. There we go. So this polygon is inscribed in the circle, which means that the opposite angles have to add to 180. 3b plus 25 plus 6b plus 20. Okay, those must add to 180. So I'm going to circle my like terms, and I'm going to add my like terms. 3b's plus 6b's gives me 9b's, and then 25 plus 20 is 45. Okay, I'm going to subtract 45 from both sides, and that is 135. Okay, we're still trying to get the b all by itself, so you need to divide by 9, and then I get that b is 15. Okay. Is that what the problem's asking for? You have to go back and read. And the problem is not asking for b, it's asking for the measure of each angle. So the first one it wants to know is, what is the measure of angle K? What I have to do is substitute b back in to this expression. Okay, just put all that in your calculator. Okay, put all that in your calculator and you will get 81. So angle K is 81 degrees. Same thing for G. We need to substitute 15 in for B to find angle G. Alright, so just throw all that in your calculator, right, and you're going to get 70. So angle G is 70 degrees. Now it wants to know angle H. Let's see, before we find angle H, let's find angle G. Let's find J. Let's find angle J. So 6 times 15 plus 20, angle J is 110. Now let's find angle H. So in a polygon, you should remember that there are 360 degrees total in a polygon. So if I take 360 degrees and I subtract all of my known angles, I will end up with my unknown angle. Let's see, it was 110, 81, and 70. Okay, and then I get 99. 99. Okay, there's all 4 of my angles. Right, so the practice is in Google Classroom, and you have to do 9.5 and 9.6. Practice and make sure you watch both videos too.